Doing a quick tutorial about how to kind of start a project on QGIS from scratch. I'm going to tell you how to bring in Google satellite images of the entire world. I'm going to tell you how to download DEMs from Open Topography plugin, and I'll also show kind of how I go about creating a new project for any remote sensing aspect. So the first thing I like to do is add satellite imagery. It just gives you a good reference frame for where you're studying. So what you're going to do first and foremost is go over to your browser, come down to XYZ files, and you see I already have a couple rasters in here already. So right click that XYZ file, go to new connection, and then I'm going to name this Google Satellite. And then so Google has servers that automatically kind of have this satellite imagery available. There's no plugin required for this. This is built in through QGIS, through their XYZ tile server provider. So it's a really handy tool to have. And there's multiple different base maps that you can add through this XYZ tool. So Bing Aerial, Google Road, OpenStreetMap if you're trying to geo-reference some map. But the one that I like to use and I use most often is Google Satellite. So this is the URL right here. So I'm going to copy and then paste that into the URL here. And then that's all you have to do. You just press OK, and you can see it's added to your XYZ tiles here to the left. And then add layer to project, and there you have. You have a global, high resolution, relatively quick loading global satellite imagery for the entire world. So that's how you get satellite imagery kind of loaded in to QGIS, which is super handy. So the next thing I usually do is start looking for elevation data. So what I'm going to do is add a group in my layers so I can separate my base map from my elevation data. And what I've done is I've gone and installed this OpenTopo plugin. So this is a plugin serviced by Open Topography, and they have global DEMs of the entire world pretty much. So what you're going to do is go into plugins, go into manage and install plugins, and then in all you can just search Open Topography DEM downloader, and it pops up. You can see it's kind of got some ratings, got a description of what it does. And so what you're going to do is install plugin right here. See, I've already installed it, so I don't have to do anything. And then all you have to do is close. So now you should have this little Open Topography logo here in your plugins toolbar up at the top. So you just click that, and then it opens up this toolbox screen, and you can choose here which DEM you would like to download. I usually go with SRTM 30 meters, but Copernicus would be good. ALOS is fine as well. They're all global digital elevation models based on satellite imagery, so they should be fine as long as you have 30 meters or whatever resolution you're looking for. So the next step is define the extent to download. So what I usually like to do is, here I am in the East African Rift system. I've kind of got the western branch and the eastern branch, so this is fine for me. And then what I do is go to use map canvas, and then that just automatically fills in based on the rectangle of where your map is being drawn. Another option is you can draw on canvas. So I've clicked that, and what you do is just draw a rectangle on your map, and that automatically loads those coordinates into your data extent. So the next important part is this API key. So an API key is just kind of a password from Open Topography that lets them know that you've created an account and you do indeed have access to download these DEMs. So how you go about that is going to opentopography.com.org, and it should pop up something like this. This is just the blog post about how to obtain an API key. But you go to My Open Topo, make sure you logged in. If you have a KU ID, a KU email, I would use that to log in just so they know you're an academic and you're looking for DEMs for academic research. And then here at the bottom under My Account, you have My OpenTopo authorizations and API key. So you just click that, and you request an API key, and here it is. Just pops up right here. So you copy and paste this key, and you go back to your QGIS toolbox, you paste that in there, and there's your API key, your password letting OpenTopography know that you are able to access these DEMs. So what I also like to do is I like to save this DEM that I'm going to download as a file. So this saves it as a GeoTIFF. So for future use, if you want to use the raster for topographic analysis with Topo Toolkit or anything like that, it's really handy to have these GeoTIFFs just somewhere that you can use in the future. So naming your files is super important. So I'm going to name this East African Rift System. Let's do Open Topo SRTM, and this is a 30-meter resolution data set. So I've saved the file there. I'm going to save it and then run. And sometimes your API key won't work. You can just try it a couple times. I've found if you just zoom in a little bit, it might work, or change your extent. This is just the OpenTopography server being slow. You can try to recopy and paste your key, see if that works. But usually it's an OpenTopography side of things. Change parameters. Run. Your API key. Let's change the extent again. Let's just get an Albertine Rift system. Change parameters, use map extent, run. And there we go, it finally accepted it. So it might be just the size of the download, the size of the raster that you're trying to download. It might be an area, but most likely it's just a ping issue, a server issue with OpenTopography. So just play around with it a little bit, change your map extent, and see if it works. So you can see here that the plugin is downloading these rasters. And once it's done, it's loaded into my project. And here now I have a 30-meter resolution GeoTIFF raster of the Albertine Graben, which is really nice. It was really fast. So this is a DEM. It's a digital elevation model, right? It does have elevation points, and you can choose to go into symbology and choose hillshade. But if you apply that, you'll notice that the hillshade does not look good at all. And this is due to a z-factor calculation that the raster does when trying to create a hillshade. So in order to rectify this, what I usually do is go to Processing, open up your toolbox, and then search for the hillshade tool in QGIS. So you double click that, it opens up the hillshade tool. You choose which DEM, which raster you want to choose. I'm going to use the 30-meter DEM from SRTM. And then the next important factor is, rectifying this z-factor calculation. So this is based on reprojections of the elevation data. And what you're going to want to do is so I found this website by ArcGIS, by Esri, about setting the z-factor parameter correctly. So if you scroll down, it has this really handy chart. So based on your latitude and whether or not your DEM is in meters or feet, depends on which z-factor you want to set the tool to, the hillshade tool to make the hillshade look good. So we're in Uganda. We're pretty much at the equator, so I'm just going to use this. You don't have to be super precise, but if I was in Oregon, the latitude of Bend, Oregon is around 44, so I would probably just use this number right here, or maybe 1, 2, 0, 0, increase it a little bit somewhere in between these two numbers, but setting the z-factor in the hillshade tool is the most important. So since we're at the equator, I'm going to use the equator number. Azimuth, I usually like 45, 45. And again, I'm going to save this file to my computer just so I have it in the future, and it's always there when I open up QGIS. So set my Z factor correctly, I've set my azimuth, my angle, I've saved it. I want to open it up in my project after I've run this tool, so I'll run it, let it sit. And once it's done, it might take a while depending on the size of your raster. There it goes. It's added this hillshade to my project. It looks much better than it did before. You can see the details of the fault very clearly, the shoreline, the volcanics, all the drainages, so on and so forth. So this is really nice for doing kind of large-scale fault mapping, or looking at different features. If you want to do large-scale KSN analysis or anything like that, drawing topographic profiles across big fault systems, 30 meters is going to be more than handy. The other thing I like to do, just to make it look nice for figures and so forth, is I'm actually going to bring this DEM above my hillshade layer in the layer properties. So you can see here now that the hillshade is below my DEM and my DEM is on top. Then I'm going to go into the properties of the DEM, and I'm going to change the symbology from a single band gray to a paletted and unique value. And then where it says the color ramp, instead of random colors, I want to go in here and I want to add a new color ramp. Then you're going to choose the catalog CPT city and press OK. And then the one that I usually like to use, there's a bunch of different options in here, but the one that I see most often, and the one that I like to use, is this wiki continuous by Schwarzwald. So you can see here there's some that have distinct different bins of elevation, but I like the continuous one. I just think it looks the nicest. So I'm going to press OK, and then you're going to classify, and this is going to classify which elevations correspond to which color on this color ramp. And this might take a while. It's looking at a lot of elevation data points. Here it's loading. Okay, so now it's classified each color based on each elevation. Then I'm going to go into transparency, and I'm going to reduce this transparency to, let's say, about 35. And then I'm going to press OK. And now this DEM has changed to different colors based on elevation, and the transparency is reduced so you can still see the hillshade through the elevation. So I think this is a really good visualization tool to just at a glance not only see the topography from the hillshade, but also relative elevations of the topography based on the overlying DEM. So you can see here the Rensworry Mountains to the south, very high elevation, and then Albertine Graben is a lake. So this is a basin, this is low elevation, and then the rift bounding faults are here as well. Something else you can do if you really want is go in here and set the min-max of the elevation, and that's going to be somewhere in here, but that's something for another day. Anyway, so that's what I like to do when I start a project, and now I can go in and map. I can do my topo analysis. I can create fault lines. I can map geomorphology, so on and so forth. Another thing you can do if you really want is do a slope layer. So this is going to just need to be the same Z factor as your hillshade if you do choose to do this. And then again, I'm just going to save it as a TIFF, so it'll always be there. And then I'm going to run it. And then this is just another visualization tool to kind of see the relative slopes. This is really good for picking out faults, scarps, or different fluvial terraces. So see the white values, the higher values, indicate a steeper slope, and the darker values indicate a shallow slope or almost horizontal. So what I like to do is actually put this between my hillshade and my DEM. And so that way, when I come in here and I reduce the transparency of the slope layer, it just makes it pop just a little bit more in terms of the topography. So you can see, if we zoom in, we can still see the hillshade. The hillshade looks nice, and then the slope kind of tells you, what slopes are relative to the other ones. You can see the fault scarp is this light color, and then the DEM laid on top of that shows you the relative elevations. So that's it. Maybe I'll do some other tutorials at another point, but for now, this is it. Thanks.